pretty early. People are still trying to trickle in. But I want to get it started so we can have time to listen to all the brilliant speakers that we have lined up here today. All right. I'm not sure if this is working. Can someone help me, please? All right. Okay. So today we are going to have conversation for EIPs right from beginning till the end, how we deploy it on the mainnet. That's why I have called it From Research to Reality. It's a journey of EIP that we are going to see here today. We recently celebrated 10 years of building, 10 years of Ethereum working non-stop. And this 10 years have provided us a lot of things. We have over 1,000 standards in Ethereum repository. Those are for protocol level, application level, layer 2, so on and so forth. But it's a great contribution of all the people who are trying to help support Ethereum grow. We have, including Genesis, 19 upgrades so far. Currently running 2 layers. We moved from proof of work to proof of stake. It was a big deal. And celebration of 10 years is also very, very big deal. We have deployed over 74 EIPs with network upgrade. Of course, there are some EIPs which goes outside network upgrade, but with network upgrade, we did deploy 74 EIPs. As you can see here in the bottom of the chart, we are increasing the number of proposals every upgrade. And this upgrade that we are expecting in the first week of December is going to be even bigger. So I would like to take a moment to thank everyone, right from authors, editors, and implementers, testers, contributors, everybody who has contributed to Ethereum Improvement Proposals, providing us such a great repository here. Today in EIP Summit, we have a great lineup of speakers, and they would be talking about how a proposal starts, what they do in order to make sure that it goes as state-of-art proposal. There are testing team involved, there are specs team involved, there are client team involved, and there are authors who would like to share their journey. So I hope by the end of this event, you should have a very good picture of the Ethereum community and the ethics that is being followed here. And maybe it can inspire you to be one of the contributors as well. I would like to see Ethereum upgrade, Ethereum journey, as a musical concert. So just imagine for a minute, like Ethereum is a band, okay? And the upgrade that we have is a live concert. And people are working hard to make sure that everything goes right. I would also like to consider an EIP as a song, like one song that can be played in the concert. So I want to provide this high-level picture of what Ethereum Improvement Proposal is, how we work towards network upgrade, and how we are celebrating our success in this ecosystem. Let's begin this musical journey. So every EIP, if we consider that as a song, then it has to be first conceived, written, composed, rehearsed, and there are so much of fine-tuning that happens to finally get a state-of-art music that can be selected for a concert that can be played in the concert. That means that can be deployed on the Ethereum main network. So keeping this high-level concept in mind, we are just moving forward to just see how we are reaching there to network upgrade. So our journey begins from research to reality. Everything starts with one simple question: what if? What if we can do this? What if we can do that? And in world of blockchain, Ethereum or any other blockchain, the very basic questions are, what if transactions could be cheaper? What if we can have a staking be more decentralized? And things like that. Of course, I have put very simple questions on the board, but you can think about how we can use AI, how we can go make use of Zcash, how we can be more private, and like privacy is a big thing here in the blockchain ecosystem. So there are questions, and these questions come up maybe in your daily work, you are thinking about it. You can be in a conference and come up with a question, oh, what if? Like here in Devconnect, a few days earlier, I read about, what if we have a better coffee here, right? So people were complaining about coffee. So someone has to say a word, and then people start working towards it. So we do have a better coffee machine here right now in Devconnect. So yeah, everything starts with one simple question, what if? With what if, there are some people who come forward and try to start thinking about it and try to document that. A proposal, yeah, not a like complete spec and everything, but something that can lead people to take it forward, and that is documented at ETH Research. It's basically a concept, it's not code yet. The concept is added, then people start taking a look at it, they want to come and say, okay, fine, this is feasible, this is not feasible, I would like to have this thing added to this proposal, and it will make everybody's life even more simpler and useful. And that's the beginning of the Upgrade Symphony. An EIP is a simple idea that is picked up by an author from ETH Research Forum. It has to be documented using EIP template, and that is added to EIP GitHub repository, where it is assigned a number by an EIP editor, and that's how we take it forward. This EIP is being discussed at multiple places. There are 2 different layers, so there are 2 different kinds of meeting that happens. Is all core dev execution, all core dev consensus, but now we also have a group who are dedicatedly spending their time to test it. So we also have all core dev testing meetings where these proposals are being discussed. Of course, we have a very good forum called Fellowship of Ethereum Magician, where anybody can come and add their thoughts, add their ideas. With this, we are trying to go forward with the Upgrade Symphony. You can consider that as an example, like, okay, fine, let's consider author to be who writes the song here, and then client teams who are the singers, and it has to be performed in harmony, so we go through different processes around here. We do have regress conversation, regress testing, and it goes back and forth. It's kind of loop until we reach to the place where we feel that this is very safe, and we can deploy it on the Ethereum main network. So this is the place where research meets realities, and we think that we have received another melody that can be played in the live concert at the live upgrade. It takes a lot of hard work to coordinate because there are so many teams, there are so many people working behind the scene. So I really want to thank everyone involved in here. This is a glimpse of the process from past and present. So earlier in the days, it was very simple. Like in my slides in the beginning, if you have noticed, there are 1 proposal, 2 proposal getting into the upgrades. But now we are going in with 10+ proposals. So many songs to be played, so many rehearsals are required, so many teams involved. So earlier, like back in the days, it was just like you draft. You think of an idea, draft a proposal, put it to last call. If it is accepted by the client team, it will go to the final, and it will be deployed on the network upgrade. Very simple. But now, we have added some ideas around how to make it even better, the process. We are working towards improving the process because we are getting like hundreds of proposals for consideration. So for these proposals, and for people to keep track of, like, okay, what is going in the next upgrade, there are different terms. And that is explained in this EIP, where we say, okay, this is proposed for inclusion. That means people can propose that. Then we go ahead with, like, okay, fine, we want to consider it for inclusion, then schedule for inclusion, and finally it is included. If for any chance a proposal is proposed but cannot be included in that upgrade, that is kind of deferred. And for that upgrade, it could be declined, but it can be resurfaced in the next upgrade, and we can consider it, unless the idea has been superseded by something else. So what do we learn here? We learn here that every EIP is a story of the collaboration, the concept, and the consensus that we comes around through this regress process. I would like to end up my presentation by stating that Ethereum is not a final product. It's a living process, and everyone has a role to play in. And in next few minutes, you're going to meet all those people who are engaged in this process. We were supposed to join by an editor who has contributed a lot in making sure that The proposals are good. The proposals are ready to be included in the upgrade. We could not have him here today, but we do have a message from him.
Welcome to the EIP Summit. If you don't already know me, my name is Sam, and I'm an EIP ERC editor. I'm the biggest hurdle you have to overcome to get your proposals published. Unfortunately, I couldn't make it to Argentina this year, but I've been asked to make a quick video for you all instead. For authors, the most important things you need to do to ensure a smooth experience are reading EIP 1. It explains our process and a lot of our rules. Read the error messages that our tools spit out, like EIP-W. It also provides documentation links, so please read those too. You need to open pull requests. The process is entirely author-driven, so when you believe your proposal is ready, it's your job to move it forwards. We also host weekly office hour calls. You can come chat with us about your proposals. You can find the schedule on the Ethereum/PM's GitHub repository. Our role as editors is to faithfully preserve changes to the Ethereum ecosystem. And not just that, the reasoning behind them. The biggest annoyances in the process, like preventing external links, are to try and accomplish that goal. If you'd like to learn more or participate in the EIP process, please take a look at EIP 5069 and consider coming out to our monthly governance calls. We're always looking for new contributors. If you're confident in your English, you can start reviewing pull requests, and if you're aligned with us, you can eventually become an editor too. If you're a Rust developer, hit me up. I have a tooling rewrite I've been putting off for over a year. Thank you all for coming out, and I really look forward to hearing about what you've all discussed. Take care.
For this beautiful message. As he mentioned, if you're aligned, you can be one of us. You can be one who can support the process. I'm very happy to invite my next speaker here, who is our recent most addition to EIP editing team. I would like to invite on the stage next, Joachim.
Yes. Hello. Yeah, that works. Okay, interesting, because this is not the title of the presentation I wanted to give. Do you have like an... yes. Let's see. Okay. Yes. Oh wait, yeah, here we go. Okay. Hello everyone. Okay, let's try again. Yes, now it works. Okay. Okay, great. Yes, this was the presentation I wanted to give. So my talk is about don't just use Ethereum, help shape it. I'm Jochem. I'm from the prototyping team of the EF. And one of the things which I really like to do is reviewing EIPs. So what I do is when I drink some coffee, like this one, I will open up the EIPs repository. I will see if there are new EIPs, and then I will check out this EIP and think, okay, is it like a great idea? Is it not a great idea? And well, maybe this EIP itself is not very clear, so then I will leave feedback. And maybe just to check, like, who of you in this room is an Ethereum Magicians user? So who of you has an account there? Okay, that's great, because that's actually more than I expected. And who of you also knows, who of you heard about Ethereum Magicians? Okay, that's almost the same people, so that's interesting. So the Ethereum Magicians forum, it's like the place where the discussions go, where feedback goes. We currently have 9,000 users, and well, as you all know, we have like tons of daily Ethereum users, but only a handful of them participate in improvement discussions. So imagine this. I have like a great idea. I want to build a coffee bar. So I have this, well, I have created this EIP 9 times 9. And well, I create this idea, and it's also really nice because Pooja just mentioned about the coffee at Devconnect. This is also like some part of feedback, how we can improve like the venue or like the event for everyone. Well, what I'm doing with this proposal, I want to create like this coffee bar, and what is happening now is that there is no feedback on the proposal itself. So I think, okay, great, this my idea apparently looks good. Then I go to ACD, we do like a temperature check there, and well, just like you know how you should drink coffee, you should drink coffee hot. The ACD says, well, great idea, let's do it. However, then we actually start to build the proposal, and well, you can see like on the right what happens. You can also see on the left my proposal. Build a coffee bar inside the desert. Well, that's an interesting idea. We use a great coffee machine. Okay, which one? And the roof says tea. Well, that looks a little bit weird and it looks wrong to me. So there are like many problems with this EIP. So the result is that people are actually going to start building this thing, and this is like a sunk cost. So people start building this, and then they realize, well, this idea is not very good. And for me, like as an author, I get somewhat irritated because I did not get any feedback, and then later on in the process, people say, yeah, okay, but like you should have done this and this and this, and I think, okay, but why? Because you did not give me any feedback. So the end result is that we do not get a coffee bar. That's not nice. And we might also demolish the coffee bar. So we have started building this thing, and then we demolish it. So we have like this sunk cost. So this is like an analogy with the EIP process. EIPs work the same. And then the question is, why is there so much silence? Because as I just mentioned, there are like, well, 9,000 Ethereum Magicians users. We have like tons of daily Ethereum users, and there is like almost no feedback. So I just checked like last week on the Ethereum Magicians forum, there were only 20 posts in the EIPs category. Only 20, and this includes new threads about new EIP. So this feedback is not there. So what I am also seeing is that like discussions about EIPs, they are there, but they are not at the Magicians forum. So we see them on Telegram, we see them on Signal, we see them on Discord, and this is maybe like also one of the, well, problems, because if you want to discuss something, then you need to know like where are these discussions actually where are these happening. So what we really want is that like a summary of these discussions. Like it is logical that you, when you talk to people, that you don't do this via a forum. But what we like to see is that these, the summary of this discussion ends up at Ethereum Magicians. Because when we do that, then people know that people have discussed this thing and also what the outcome of this is. So we don't have to do the same discussion again. And then we also know like, okay, this discussion is happening there, or you should talk to these people. So also about like the discussion point itself, like you could also point like, yeah, we have this thread on Discord, or we have like this channel in Telegram, or we have like this Signal or whatever. Like no one is going to come to your channel and then scroll back 1,000 messages and read it again. People are also not going to rewatch like a breakout call or like whatever. That's not going to happen. Like we really want like a summary to that people can like quickly get up to date, like what's actually going on, what are we discussing. So what we want is that people post summaries on the Ethereum Magicians. So the end result is that this decreases the total time of the community what is spent on like an EIP. Because you could imagine that there is like some research going on, and that no one of these, like there are two research teams, they are doing this research, and they do not actually know that that the other team is doing exactly the same research. So at some point they find out, okay, great, we are doing the same thing, but now we have, well, I will not say waste time, but like everything which is done 2 times, like the time spent on that could also have been spent on other things, like for instance, other EIPs or other research. So that's one of the things I want to give to people, like, okay, if you have like a discussion or you have like an opinion or whatever, like please post a summary on Ethereum Magicians. And this would especially apply to core developers, because this only takes 1 minute of work, and it saves a gigantic amount of spend time, because now you know, okay, people are, like the EIP author, you now know, okay, people are working on this, they have like some problem, then you can go back, you can ask these people, okay, you apparently had this problem, what should we do to fix this? So, the optimal process, that's what we want to optimize, is we want to minimize the total time of everyone. So, you want to provide this feedback at a central place. So this is then Ethereum Magicians. So not some Telegram channel, not some Discord thread, or not some Signal channel somewhere. And this this feedback should then include concerns, or like how should we address these concerns. And the EIP itself, that's like the entry point of these kinds of discussions or research. It should be self-contained. So it should not have like some assumptions, like some technical jargon, like which is used in certain research groups. Like you should take an EIP, you should only read it once, and then you should realize, okay, this is what's going on, this is the entire idea, and this is this is what the EIP wants. So you can also implement it from the EIP in one go. So now the question is, how can you help here? Well, of course, this is the main message, is to provide feedback, because communication is key, also with the EIP process. And I think one of the reasons why there is not so many feedback done, also on Ethereum Magicians, but also in general, is that there might be some misconceptions. So I think to enter the EIP process, people might perceive this as to have like a very high mental barrier to enter the EIP process. So I think the biggest myth is that people need to be a core developer. So you need to be like super deep into the protocol and like have a super deep understanding of like what is Ethereum, how does the protocol work. This is just not true to help with the EIP process. So what you can do, you can take an EIP, you can read it, and then you can provide feedback over the quality of the EIP. So you could say, okay, like this thing is defined in section 2, but it is actually referred to in section 1. So that means you cannot read or understand the EIP in one go, because then you first have to be at, well, you have to basically do the search in the EIP itself. Like it's in section 1, it refers to some constant, which is actually defined in section 2. That's not nice. And people who are writing this EIP, they might not realize this, because this constant itself is in people's head. Like they know, oh yeah, this constant, like we use it everywhere, so you know it. So when reading this EIP, when proofreading your own EIP, there's a very high chance that you don't realize that this constant is defined later on, and that you should actually move this before. So this is like a very simple thing. You can read the EIP, then you go to Magicians and say, oh, hey, listen, I see that you are using this constant, but it's defined in a later section. Another myth is that, and I think this is one thing I realized myself, well, very late, I would say, is I was always afraid to ask like some question or make a point, which I thought, okay, this is just like a very dumb question, or like a very dumb point. I think that there actually are no dumb questions, and there are no dumb points to be made with EIPs, because sometimes an EIP might be confusing to read. And like, if you ask like this dumb question, like when you ask these things, then the author might first think like, wow, okay, this is like such like a simple question. But then the author might realize, oh, okay, wait, but I might actually be explaining this thing in a very confusing way. And then people will, then authors will go back to the EIP and make this better. So yeah, so the reality is like this, the confusion points of the EIP. And there might also be a question like, why do you want to do this? So the EIP itself, like it might be technically correct, but people might think, okay, why would you even want this? And this is especially, I would say, especially important for smart contract developers and also people who use smart contracts. Like for instance, well, basically anyone who uses a smart contract, so decentralized exchanges or like whatever. Like if you find a problem or like you have some challenges which you want to solve, and one of these EIPs solves them, go to Ethereum Magicians, say, oh wow, great, we have this project and this EIP would like make our entire process much faster to solve and much better. One of the other myths is that people assume that an EIP is getting enough attention. So, oh, there's this EIP proposed, and well, it might have been on the agenda of ACT, so Alcohol Devs, and that people assume that it has enough attention. Well, the thing is, and I would really say this also to everyone here, like people have a very limited attention and really get involved into the topics you care about, because usually it turns out that either no one or like one or two persons are looking into this, and we really want to crank this up. So let's see how can you provide good feedback, or well, from the EIP which I proposed, like how can you do this? So for instance, this thing was like, okay, build a coffee bar inside the desert. We go to Ethereum Magicians, and then you ask, okay, why do you want to build it in a desert? Because like I love coffee, but I'm not going to travel to this coffee bar inside this desert. Yes, thank you. The second thing is about like, okay, we want to use like this great coffee machine. Okay, but yeah, what is a great coffee machine? Like what do you mean with this? No, did you look into the Devconnect coffee, for instance? And the second, the last thing is, okay, the roof says tea. Well, that looks wrong. So I think that actually should look coffee. Should say coffee. And you can also like have like some response about the entire EIP. Like, okay, if you have like an internal discussion about it, then the idea itself looks fine. But the problem is that, well, it actually has no seats and there is also like no roof. And that, well, and that might be like, well, it depends, but some group will not support this building. And that they also endorse all the previous feedback. So after we've done this feedback and all these cycles, then what's happening? Well, look, now we have provided this feedback and now everyone is happy and we have like this very great EIP. So, what to do? The first thing is that you should stay up to date with the latest EIP changes. And the best way to do this is you go to GitHub, you go to Ethereum, and then the EIP's directory, the EIP's repository, and then you watch the repository and you say, oh, activity. Well, just a heads up, you will get like a lot of notifications, but you will also know when like a new EIP is being added. And if you have then feedback on these EIPs, then post your feedback or your discussion summaries into Ethereum Magicians. So the URL is also there, ethereum-magicians.org. Create an account, do it today. And yeah, as I mentioned, like a few minutes of feedback will reduce the total time of everyone spent by tons. And also like any time spent on doing work done by others or in the past, that's time which could be spent better elsewhere. So about these EIPs, like when you have, when you have added yourself to like watch this repository, like try to at least review one EIPs per week, find an EIP, read it, and then provide feedback. And you can also go to the eips.ethereum.org and then look there, like okay, what looks interesting, and let's do that. All right, that was my talk. Thanks a lot. Here are my handles for Telegram, Discord, and X. And well, hope to see your reviews very soon. Thank you.
Are there any questions? We have 5 minutes. If there are any questions, people interested in how we can participate. Yes, there is one.
Hi, how are you? I would like to know the difference between EIP and ERC. And also another question, if I write an EIP about everything I want.
Sorry, can you repeat the
like
last
a
question?
Limit or, sorry?
Can you repeat the last question?
The last question? Yes. If I can write an EIP about everything I want, or I have to follow some specific things or subject.
Okay, so the first question was, what's the difference between EIPs and ERCs? So like a very high level response, or well, that's actually, I'm looking at to Pooja, but the EIPs is about like the core protocol, and the ERCs are the application layer. Okay, great. Yes, thank you. So these are like really oriented, like for instance, like ERC20, that's like the ERC20 token specification, like how you should write this contract interface for like tokens. The second question is like, if I have like an EIP, you have an idea, like how should you do this? This process is in EIP 1, I think. Yes. Okay, great. I got a thumbs up from Pooja, so that's it. It is in EIP 1. So this has like the entire process and also like the format of how you should do this. And also, like if you open like a draft EIP, like you will get an ETH bot on GitHub, and it will say this is wrong, this is wrong, this is wrong, and it will help to fix these things. So this should not be a barrier to write your EIP. And you can, of course, also reach out to us. Like we really love to help you. Yes.
As we mentioned in the beginning of this presentation and in the beginning of this summit, there are so many things around, and we are around to help you out. If you have any other further question, I guess we have 2 more minutes before we have our next speaker. So if there are any more questions, please ask. Otherwise, we are around, and you can come and meet us at the backstage.
So you've covered ETH research and Ethereum magicians, and seeing the amount of hands that were raised about who is partaking in ETH research actively or ETH magicians here. Would you be able to maybe walk through the reasons someone would post on ETH research or read on ETH research versus on magicians?
So this was mainly about Ethereum magicians. And the reason for this is like the feedback loop. So really, like if there's no feedback, then there's no way it's an improvement proposal, and there is no way to improve your improvement proposal if there is no feedback. So that will be for Ethereum magicians. For ETH research, I will not be able to answer that now, but I think also for that, like it's also about feedback. Like, okay, this is wrong, this is right. Like also a feedback loop. Yes.
Actually, you have covered it pretty well. So the main difference between ETH research posts and Fellowship of Ethereum Magician posts that we expect to get is ETH research is only the idea. That may or may not be a proposal at the time. But eventually, when it is accepted, someone agrees to write and document a proposal, then we want them to open up ETH Research Magician Forum thread link for open discussion. We want to invite participation from clients, from community to see whether they are open to implement this proposal. So that's where we get into ETH Magician Forum. And before that, we are into ETH Research. Well, I think that pretty much covered the time that we have for this presentation here.
Right. Thank you.
Give a big round of applause. He is our new editor, so you're going to see him more. And yeah, please feel free to join us in the office hour. So moving ahead, our next speaker is going to talk about draft to inclusion journey of a proposal. I would like to invite Jihoon to share his story. He's an author, and he wants to share how we can make sure that proposal reaches from draft to inclusion. Welcome, Jihoon.
All right. Hello, my name is Jihoon. I'm a research engineer at the Ethereum Foundation. My role is bringing forefront research ideas into production, serving as a liaison between researchers and developers, and I'm also recently became a Bitcoin Chain spec maintainer. So this talk is about what it takes to ship an EIP. I'm going to walk through the process from the practitioner's perspective. Some EIPs go smoothly, some EIPs contentious, but I do hope this talk could give you the sense of what's it like to proposing changes to Ethereum. So let's take a look into how it makes changes to Ethereum. Ethereum protocol is evolving. It has a governance process that decides what goes into the protocol. Governance can be either on-chain or off-chain. On-chain governance is when protocol changes are decided by on-chain voting, typically by governance token holders, whereas in off-chain governance, a process of social discussion makes decisions, and the decisions are implemented in code later. Ethereum has adopted off-chain governance. Roughly speaking, when you have an idea of proposing some change, you want to write it as a proposal. You want to discuss with as many people as you can to flesh out your idea. You're going to use write-ups, either in the Discord, ETH Research, Ethereum Magicians, or Twitter, Signal, or whatever, to share and discuss your idea. And then you're going to write an EIP. How to write an EIP is a different topic, but there will be a talk regarding that, so please check it out later. Now, let's say that you want to advocate for your EIP. We call those people EIP champions. As an EIP champion, you want to demonstrate that the proposal is valuable for Ethereum, technically sound and reasonable, and has higher priority than others. We decide which proposal to implement in All Core Devs Call. It held every Monday and Thursday at 14 UTC. It's open for everyone, so you can present your proposal there. You should be able to find a GitHub issue under the Ethereum PM repo. You can leave a comment there about what you want to discuss during the call. And if the moderator finds it relevant to the call, then you will have a chance to discuss. So if everything goes well and people approve your proposal, it will be included in an upgrade. Of course, there are many back and forth and iterations, but we will jump into it later. So that's the overview. Now, let's say that you have your EIP prepared. You've done lots of research. You went through the EIP review process. You got your EIP number. You shared it on your Twitter. You got many likes. Great. Now, you are in the beginning of your journey. Writing an EIP is definitely a good milestone, but it's like you are at 5% there. So idea doesn't talk itself. You want to have people learn about your EIP and then convince them to include it in a fork. If your change is small or not contentious, then it could go smoothly, but it might not always be the case. People are not always agree with you. People might be too busy to take a look into your proposal. People might just misunderstand your proposal. So you probably want to share some write-ups or Twitter threads that capture the gist of your proposal. You could also do podcasts. You can answer many questions in the Discord. You probably going to find yourself repeating the same things over and over again, so you better be prepared. And sometimes people come to you and say, I broke your design, but actually when you look into that, that's actually on top of your FAQ. Sometimes people give you like great feedback, but sometimes people just don't like your proposal, but they cannot come up with why they don't like it. So there are many cases, but in any cases, you should be able to convince yourself in order to convince other people. So you will have to communicate with people a lot. You want to reach out to different stakeholders, such as researchers, client developers, application developers, staking communities, L2s, builders, you name it. You basically want to have them on your side to back your proposal. Then you need to listen to them, and if they're not pro for your proposal, then you need to figure out why and solve it. So basically, you should be able to answer the question of why do we need it? Is it valuable? Does it have to happen now? Is it forward compatible? Getting various feedback and having more eyes on your EIP will make it more robust. You might find some bug. You might learn something you haven't really thought about. For example, I've been working on Fossil, and we didn't know about we could use Fossil as a force inclusion mechanism for L2s. That's what we learned down the road. It might sound intimidating if you have to reach out to all of them, but as you talk with them, they will connect you with other people, and sometimes people just come to you. So every journey begins with a single step. The last point that I want to talk is, although it's not strictly necessary, there are many EIPs that are included without it, but having specifications and client implementation could go a long way. It is probably the best way to demonstrate the technical readiness of your proposal. And all core devs is, as the name suggests, is for core devs, and sometimes developers find it easier to read code rather than reading a conceptual paper. And especially if you are proposing closer to the deadline, people want to see if your proposal is mature enough. So in that case, providing a spec and implementation could be a good answer. But in reality, it doesn't always work out. So people might find other EIPs more important and more urgent than yours. Yours might turn out to be just nice to have, for example. Some people might support your EIP because it would pave the way for their favorite EIPs and something they want to achieve. But somehow things get changed, a new idea came up, and they don't want your EIP anymore. Things happen. And sometimes proposals gets killed in a later stage. It could be because some edge case is found that could invalidate the whole design. For example, EIP 7547 is a formal version of inclusion list to fossil. It was killed because there was a case that it could halt when there is some interaction with account abstraction transaction, or some previously unknown issue came up and it delays the fork more than enough, and that could be escalated to a deal breaker, unfortunately. So be aware that even if it's scheduled for a fork, it is not the end until its end. So that was pretty much what I prepared for today, formulating your idea into EIP, building the community consensus, and if it's scheduled for an upgrade, you still want to keep your eyes on it. Some unknown issue might appear, and people will come to you to ask for something because you are the one who knows all the history. So it might look like a lot to take in, but All Core Devs Call is open for everyone, and if your idea is a good idea, people will recognize it, and there are people, including myself, who are working on Ethereum for full time, and you can always collaborate with them. So Ethereum is an open source, and I would encourage you to contribute to Ethereum, and thank you for your listening.
So we have got another 4 minutes. If there are any questions. If not, then I would hope that you guys should consider taking a look at not Fellowship of Ethereum Magician, but also the ETH Research Forum, and consider being an author and helping us out. All right, we are around, and we are, I guess, 3-4 minutes ahead of time. So if there are any questions or anything that you would like to know about the process, please raise your hand.
Hello, I've been out of the process for quite a while, but the numbers start creeping high and we're in the 7,000s. There was a long time ago discussion of once we get past 10,000, do we do like 11xxx is going to be for a particular sort of change, and 12xxx will be another, and we'll divide up that way. What's the development been? Is this just like we're going to soon get EIP 13,055 and it's just going to be the same as like 14,055 and it will just be chronological? The GitHub repo situation, like what's the movement there? From like the past 5 years, or the evolution of this, if that's fine.
All right, I think I can perhaps take this one. So earlier, the way we used to allocate EIP number was based on the pull request. And that's how we reached to the number that we do not have those number of EIPs as we have number of Number of PRs, that's right, yeah. So we have stopped it actually. We are now going sequentially. So you would not be able to get a special number just by making your entry in the GitHub pull request as like very special number. No, that's not how it works anymore. So the way it works right now on today's date is like you have to make a pull request. We have a team, of course, editors allocate the PR numbers, but we do have people who are helping out. They are called associate editors. They will take a look. We are trying to get it done in next 24 hours after your PR is there, and that's how you are getting the number. We are in process of making this process automated, so we don't need intervention of editor or the associate editors. But while we reach there, this is the present process. And yes, we are not going to get a huge number for EIPs very soon. Thank you. And any more question? We have 2 more minutes. I can perhaps take one more.
Hey, Jihoon. What would you say has been the most troublesome part of your entire journey to pushing Fossil, and how would you go about recommending to fix that?
All right, Phil, it's a good question. Just give me a moment. There are a lot.
The best one.
The best one. I would say the moment we CFI'd Fossil, I mean the moment before we did it, like in the Berlin interop, when we as in like people who've been working on Fossil, ask people around like, what do you think about Fossil? Do you want to ship it? And then the response was like nearly, I would say like 98-ish people were like, great, we want Fossil, we want censorship resistance, it's important, but it turns out that it may not be true, like because of priority for cadence, complexity. I get that because like, you know, things are always changing and people always change their opinion because they learn something new every day. There was kind of a little bit of a surprising news for me because I thought that there will be no hurdle for Fossil to get in. Still is struggling, and we don't know how it's going to be like after like 2 weeks, for example. And your last question would be how would I recommend to amend it? Honestly, I don't have a good answer to that question. If you want to try to tackle it, then we need to define like what the problem is. Like, do we agree that that's a problem? Yeah, I think many things boils down to coordination across different stakeholders who measure things in different values, and I'm not sure, to be honest.
Maybe if that is of any comfort, I have seen proposals getting out of upgrades list just a day before the upgrade goes live. So this is not the end of the journey of a proposal. We could see more proposals getting in, and there are possibilities. Sometimes we give a break to a proposal, assuming that either the proposal is not fully ready or the team is not fully ready to implement that proposal alongside of many other proposals which are getting in. So I would like to wish you all the best. We would love for all the work that you have done here, and we hope that we could see it in the next upgrade. Thank you, Jihoon.
Thank you, Pooja.
All right, it's time for our next speaker. So our next speaker is someone with a great team who has to make a lot of effort. A lot means really, really lot, because without that, we would not be having successful upgrades. I would like to welcome Paritosh Jayanti, who is with ETH Panda Ops team, where all the testing work goes in. Welcome, Pari.
Hey. Thank you for the kind words, and thanks for having me here. So today we're going to be talking about how we go from specification to syncing a node. I was told then that it should have been spec to mainnet, but that doesn't have the catchy vibe, I guess. Before we move on, look up from your phones. There's about a 60-second TLDR, and you can move back to your phones later if you want. So I'm going to talk about what an EIP is. I'm going to talk about how an EIP author writes the tests. I'm going to talk about what phases tests have. And I'm going to talk about, what fun tools we've built and how we're going to move on. Feel free to go back to your phones if you want. The rest of the talk will be a bit more verbose, I guess. I really like this format, by the way. Props to Kev. He tried doing it, but he wasn't allowed to do it on stage because their presentation software didn't support video, so I was very happy that this one does. So what is an EIP? An EIP is a design doc. I know that the last couple of presentations have already gone in depth about what an EIP is, how the numbering system works, etc. But the idea is that if you were to take the yellow paper, add up all the EIPs that are approved, then what you get is mainnet Ethereum. In practice, it's not that simple. There's a lot of other features involved, and that's part of the reason why we have the executable specifications today. If you're ever in doubt about where to look to understand how Ethereum works today, especially on the execution side, have a look at the executable specifications. A lot of people from that team are here today. Huge props to them. Find them, speak to them, and so on. So every change needs to contain an abstract, a motivation, specification, security considerations, and so on. This can take a bit of time to actually get the right format because you're not writing it for the average reader. You're writing it pretty much for core dev audience. And it must also come with tests. This is something we're trying to push more and more. The newer EIPs do come with tests, but in the past, I don't know, even I've submitted an EIP that just says update gas limit to XX number, which is, yeah, for the process reason we had to do it, but, well, it doesn't actually help anyone to have that, right? So we're trying to push more and more to have tests, to have a lot of these, to have more considerations happening before we move to the later stages of the development process. Once you have the EIP proposed, it goes through a bunch of phases in the life cycle. This is a screenshot I have from a talk that Lightline gave a while back. I'm sure it's on YouTube and you can find it. It shows you all the stages that it goes to. But at a very, very high level, once an EIP has been accepted, you can decide to propose it for a fork. That's when it gets included in the all core devs discussion process. And then it gets one of three statuses. It's either considered for inclusion, scheduled for inclusion, or declined for inclusion. Declines for inclusion is great for me because that means I don't have to look at it for this fork, and it's a problem for the future fork. Considered for inclusion and scheduled for inclusion implies that not only does the EIP author need to spend time with the testing teams, but also the testing teams have to spend a lot of our time understanding the EIP, the implications, and so on. Schedule for inclusion is sort of like P0 for us. This means unless we find something drastic, there's huge burden of proof to remove it, it's going in the next fork. An example of what's scheduled for inclusion for the next fork is block level access lists and EPBS. So unless there's massive new information found, we know that these two forks are going in. So in terms of team priorities, both the Steel team as well as the Panda Ops team would be allocating ample resource to these two EIPs. And we also help with all the other CFI'd EIPs, so that's the considered for inclusion ones. But they still need to prove something to, there's probably a couple of unknowns that need to be figured out, etc., before they can move to the schedule for inclusion stage. Now, let's assume we have a bunch of EIPs that are all scheduled for inclusion. What does the testing process look like? At a high level, it's this flow chart. In reality, there's no one formula for how you test a fork. It's pretty much case-by-case basis. I don't think there's a single fork we've gone into where we hadn't needed a new tool. There's probably something or the other that had to be invented or developed, just purpose-made for that fork. But at a high level, these are the phases that we're looking at, and these are most of the tools that we've settled on. I'm going to go one by one and then give you guys an idea of what we're trying to catch with each stage. So the first one's the spec tests. So earlier I told you guys the yellow paper plus the EIPs equals mainnet. Today it's the execution specifications and the combined tests that come with it that would define what mainnet is, at least on the execution layer. The Steel team is responsible for these, and we also have another parallel specification for the consensus layer. So the consensus layer specifications are also what defines the consensus layer of Ethereum. Yeah, this is probably also the most descriptive way to define an EIP. If you're ever in doubt, you should just reach out to the team how you can even think about implementing an EIP before you actually write it, just so you get a better idea of what could be important in the EIP. And yeah, tests are derived from both the repos. One of the benefits is you get these test fixtures as an output, and the test fixtures are what's consumed by the client teams, by the ETH Panda ops team, by the testing team, by Hive, and a lot of these other tools. So these are like ground zero. This is usually the starting point for when we need to do changes. The next thing we do is, let's assume that you have a bunch of these fixtures, you've tried it, it works locally. Ethereum values client diversity a lot. We have about 6 execution layer clients, 6 to 7 consensus layer clients, and this means there's a lot of options for interop. So there's about 36 combinations that we tested for Fusaka. That number seems to be trending to go upwards. And we try to make sure that you can use any combination of execution layer with any combination of beacon node with any combination of validator client. And this still doesn't include things like SSV, OBOL, middleware proxies, etc. The testing matrix is huge. And the only way we can keep this sane is by moving the tests to local first and enabling each client developer to test and catch as many bugs as possible on their machine without waiting for us to catch them. And one of the tools we use to do this is Kurtosis. So this brings up all the dependencies that you need. It spins up all the tooling that you need. It can programmatically run tests for you, everything on your local machine. We've abstracted it all away with Docker. So all you need is the Kurtosis CLI as well as Docker. One of the benefits is also, if you do find an issue, especially with a specific test, you can just share a YAML config with the other client teams, and then helps us coordinate with each other as to what the bug might be, help us reproduce it, and so on. Yeah, so this allows us to also create a rapid feedback loop. This is something that's been very useful, at least in the last year. Before, I would say 2024, the typical way we would handle interop is that the ETH Panda ops team had to get involved. We had to create these devnets. You'd have to find issues in the devnet. If I'm sleeping or someone from my team is on vacation, then tough luck. And this gives us a different angle to the approach. It just empowers the devs way more. Just a, I guess, brief summary of how this looks. This actually isn't even spun up. This is with parallel Kurtosis running, and the end of this loop is how fast it takes to spin up a devnet. The other massive tool that we tend to use very often is Hive. This has been out pretty much since the beginning of Ethereum's history. It also uses Docker, and it spins up clients. However, the easiest way to think about it is extremely fancy unit tests. So we tend to know what the input is going to be, and we know what the output is going to be. And Hive helps us assert that the input is equal to the output. We also have a GitHub action for this. So if you are a client dev or you're running a fork of Ethereum, then you can always spin up Hive yourself. However, we have a hosted instance, hive.ethpandaops.io, and this runs nightly, and all the issues that are found, especially diffs from what happened yesterday to today, are posted in the ETH R&D Discord, and this helps client teams actually see if there's regressions and get a notification about the regressions. Yeah, the bugs can be reproduced and fixed. It's invaluable for our debugging lifecycle. High-level overview, this is how it looks. There's a lot of test suites, and it's a huge repo. Have a look at the docs. It does a lot of things, but it's probably a good place to try and understand how a client EIP will function over its internal lifecycle. The next big phase is devnets. So DevNets are what are only launched once we have about 3 ELs and 3 CLs that are able to actually interop with each other. We validate this on Asserter, we make sure that Hive is passing on these clients, and then once these things are true, it's useful to start getting the community involved. It's useful for clients to publicly start joining. There's a lot of nuances with public DevNets versus local DevNets that make them a bit more fun to catch bugs in. You can have something as weird as a Cloudflare issue that suddenly leads to certain packets ending up in weirder orders that leads to a certain bug, right? So it's very, very nice for us. And yeah, attack scenarios can be tried live. So simple examples, yesterday or day before, we tried a non-finality test on Fusaka DevNet 3. And this is something that all the client devs could observe. And then we let it non-finalize for about 2 days. We healed it, and then everyone can have their local monitoring setups and try to see how their individual client is doing during recovery. Yeah, this is usually accompanied with this nice front end. It's Dora. It's our Explorer. It helps us visualize how the chain looks, how the chain health looks. There's a lot of tools that go built into this, and I'll talk about like a few of them later, but at a high level, anything we feel like we can use to probe the network, we put it in Dora. Another thing that happens is we then move to the testnet stage, and the testnet stage are long-term devnets. So you might have heard the name Hoodie, Sepolia, Girly. We had Robston in the past, Rinkeby. So these are testnets that live for a few years. We're trying to get better at like giving a life cycle for a testnet, but it's a very difficult problem in itself. We try to have a purpose for each testnet. So if you're a validator, you should go to Ephemery or to Hoodie. If you're a DApp, you should go to Sepolia. And this gives us sort of a staging scenario for different things that Ethereum is trying to take care of. And you might imagine that you want some amount of load here. So besides the load that anyone from this room or anyone else might be generating on their staging setups, we also have a tool called Spammer. And Spammer can create these fun scenarios for us that might be interesting. There's also some EVM fuzzing in there now. We don't actively EVM fuzz testnets, but sometimes we do have like shorter bursts of it. The other benefit is that testnets, since they're running for many years, tend to have a larger state. Sepolia is about a couple hundred GB. This might suck if you're someone who's just trying to launch the testnet and join, but it's very useful from a testing perspective because it helps us actually see how the client would perform on mainnet, which has a bigger state. It's also getting a bit nuanced for us because testnets initially started as a way for client developers to test their software. However, now it's also a staging environment for all of the ecosystem, which means we can't as liberally break them as we used to. We're trying to get better at only shipping, let's say, mostly validated software that has a higher bar than it used to in the past, and then moving devnets to the chaos style things that we do. The other tool in our bucket is ShadowForks. So ShadowForks are essentially copies of an existing network, and then we launch a new beacon chain, and there's a fun trick where the execution layer basically just follows whatever chain the consensus layer tells it to. So we create a new chain, and then we fork off from the main network. The benefit of this is we can now break this new network while inheriting the state of the original network. So this allows us to actually validate if configs are set up properly. It allows us to validate if we have an attack scenario, how that's going to work. ShadowForks have also been very useful for increasing the gas limit, because what we've done is we've taken a ShadowFork of mainnet, we've bloated the state, so we made it about 2 times as big, and then we start attacking this 2 times as big a state. So this can tell us that if we were to increase the gas limit in mainnet and we were to leave this for a long duration of time, how the performance of mainnet is going to degrade over time. And then we can proactively start making optimizations, figure out what EIPs need to go in before we're actually suffering from the consequences of that on mainnet. And yeah, the last bit is every time there's a fork in an EIP, it goes through this cycle of actually, oh sorry, I think I might have multiple testnet slides. Sorry about that. Yeah, it's easy to join, and yeah, node operators are on testnets as well. Another thing that we can do on testnets is because they have a larger state and are running for a while, we can actually do sync tests on them. And this would tell us how easy it is for anyone to join a new network, and in case we're breaking sync in the new network. This is a base primitive of mainnet, and we want to make sure that we never actually break sync on mainnet. And the last step of this entire process is actually scheduling mainnet and shipping on mainnet. You might have noticed that Fusaka is going through this cycle right now, and one of the feedback points that we've gotten is that a lot of L2s require some amount of time to implement the changes. Community needs some amount of time to update their software, to validate that the updated software works. So we have a staged release cycle. So you would have a testnet release, testnet fork, about a month between each thing. And once the last mainnet release has gone out, we want to keep at least a month before actual mainnet happens. So this whole cycle from starting a specification to getting scheduled, to tested, to actually deployed on mainnet, for the first time we're able to do this twice in 1 year. Hasn't been that easy to achieve. However, we're trying to do a lot more pipelining than we did in the past. So we've already started work on block level access lists, for example, already started work on EPBS. And once those testing cycles are more mature, then we'd already start with the deployment stage of testnet 1, testnet 2, mainnet. And this is a cycle we're hoping more people from this room would get involved with, help us catch issues earlier, help us catch issues before they actually become critical, and help us get to a safe mainnet. Thank you. And if you have questions, I'm happy to answer them.
All right, we have got 2 minutes. If there is any question, please raise your hand.
How can I know if my AIP idea is already created? I mean, is there a website where I can check that?
So probably the easiest way is to check the EIP GitHub repository. I'd say forecast is getting better if your EIP is scheduled for the current fork or the next fork. But I don't think it's still a generic EIP crawler, so to say.
Yeah, maybe I can add to it. So we do have a website called eips.ethereum.org. Go to that and go to alls. So you can just find, like, add your keyword and try to look into the proposals. Yes. So that is very much available over there in case you want to have a test whether this kind of proposal is already added or not. We have one more? Okay.
What do you think about the idea to have something like a shadow fork for the mainnet, where we do the fork before the mainnet fork to test the software and everything, and then follow the shadow fork together with the mainnet and see how the clients perform?
Do you mean something that's running longer term, or something that we require just for like a week or two before the fork happens?
Let's say 1-2 weeks, probably something like that.
Yeah. So this is
somewhere between the testnet fork and the mainnet fork, or in that period.
So this time we have the benefit of bloatnet being around. So we do have this ability. Bloatnet's already running the latest client releases that are meant for mainnet. So it is a mainnet shadow fork, and it's working. Once we're all back home from Devconnect, there's also another shadow fork planned with all the client teams. We tend to do one before each testnet fork and shadow fork. It's, I would say, semi-useful. If anything, it helps us make sure that there's no config issues, but in itself, it's very fork dependent. An example is Fusaka is mostly a networking change. Unless I have about 10,000 nodes to spare, it's difficult to actually test the thing. Whereas for Pectra, it was very useful. It didn't matter if it was 1 node or 2 node, you could have still caught bugs with it.
We have got 25 seconds.
Rapid fire, go.
All right. So Pari is around. If you have any further question, please come and find him. Thank you so much, Paritosh.
Thank you for having me.
All right, so far we have seen the overall process, how do we work around. We have heard from editor, like what an editor want. And we have also looked into talk from an author, like suggesting how we are moving the proposal forward. We did have a conversation with Pari here right now, talking about what DevNet can provide us, how much security is available there, but there is something in between. And our next speakers are gonna cover that. So our next speakers are going to talk about collaborative specs and test developments for faster Ethereum folks. Let me welcome Dan from Steel team and Rahul from Protocol Prototyping team. Welcome you both.
So good morning, everyone. Thanks, Pooja, for the introduction. I will be joined afterwards by, well, I'm joined by Rahul, who will talk about code is law. So we'd like to propose a small but significant change in the EIP review process that would really help us couple the specs as executable specs and the specs as markdown specs from the Ethereum EIP's repository. And this would really help us accelerate Ethereum development and avoid speculation. So thanks a lot to Parry, who gave an excellent overview of the whole process of how an EIP hits mainnet. And right now we're going to focus right in on the stage of specs and testing. So just to motivate that a little, what and why do we do specs for Ethereum? And well, the execution specs and the consensus specs repos, they basically implement the intended behavior of Ethereum as executable code. And these specs serve as a proving ground for EIP ideas. It gives a place to prototype them. And they serve as a shared source of truth that generates test vectors that can be used by client teams. And for this talk today, it's very important to remember that we really need the specs in order to generate vectors. The specs are really essential. And furthermore, they serve as clear, readable documentation. They're not optimized for performance. The specs are really optimized to be clear and readable as a reference. And well, why do we do this? Ethereum's foundation has a foundation of client diversity, which is really important. It keeps the network secure. And due to the fact that we have many client implementations, it makes sense to have this additional level of infrastructure that provides specs and tests that can be shared across the ecosystem. So working in specs and testing is really an extremely collaborative job. And we really connect teams across the core dev ecosystem from research, prototyping, and production, all the client teams. We basically help researchers and prototypers turn their EIP proposals into rigorous and unambiguous specs. And as I mentioned before, we generate test vectors and provide the test frameworks that client teams can use to verify their implementations. And so we're in a position in the middle of many teams where we have a huge potential for impact. So we collaborate with a lot of different teams, and any improvement here can really help speed up the process. So it's really, I think it's really worth focusing on the process of speccing and the infra that we have for those specs in order to accelerate Ethereum's development. And if you look in the context of Parry's talk, all the effort that goes into testing, like after specs, like everything they do, Kurtosis, AttackNet, the Hive infrastructure, shadow forks, everything, if you can catch a bug in an EIP in the spec, like just some edge case that we didn't think about, if you can catch that really early, then you're going to save a bunch of time downstream. And that's really important. And so we can really accelerate Ethereum forks. So I'm going to motivate our proposal of how we couple these things by having a look at the history of specs and testing on the execution layer, which is the area that I'm focused on. And first of all, we're going to look at the genesis. So at the beginning, specs were basically in startup mode. So we had Ethereum. That's a great thing. We went from 0 to 1. And we were testing evolving decentralized infra, which is a nice problem to have. So if you look on the right-hand side, you've got the different sort of repositories and things which represent the objects we need in order to do this testing. We've got the test cases at the top, which were originally in JSON and YAML. That was how they were expressed as source. And then you've got the test framework, and you've got the EIP's repository, which serves as the source of truth for specs. Then you have the client teams below. Can probably add a couple there later on in that era, but they somehow were the spec maybe? It was a bit unclear. As you can notice, there's no spec on the right-hand side. And before I go to the pain points, I just want to give a big shout out to Dimitri, who really generated, created, and maintained a huge corpus of tests and Ethereum tests. And these test cases are still used today. We generate them with our infrastructure. But despite that, we're in startup mode, and there are some pain points. The test cases are quite hard to read, and the tests were not parameterizable. So they're not generated programmatically. You really literally have to write a new test every time. In the next era, which starts around 2022, when the EF created a testing team, which I became part of. And the first step we did was we took a prototype from Light Client and then built it out into new testing infrastructure that we use today. And this made the tests executable code. This really helped improve the situation because we had more readable tests. You could read them more easily. It made them easily parameterizable, and that really led to faster test implementation. So as you can see on the right-hand side now, we've got the test cases in Python. Up there should say test infrastructure too. It's all bundled in the same repository, which is quite nice. It's versioned together. But the EIPs remain on the side. And the pain points in this period were more pressing than maybe what we're going to talk about today. But one of the clients acted as the spec, which is a bit weird. Don't really want to do that. That's what we're testing. And testers struggle to track MD spec changes, so we basically had to, keep an eye on the EIP's repository and make sure that, any change that came in, fixed typo, is it relevant, what's going on, keep everything, make sure what version of a spec are we on, it's not version, just a commit hash, what are we trying to spec here? And then worse than that, we really scrambled to find a spec. So we really had to go into someone's branch of some client implementation and find whether it was up to date with the spec that was on EIPs and get everyone to talk the same language and make sure we're all at the same commit hash, which is a bit of a mess. And so that was the situation during the first era. But nonetheless, it was a step in the right direction. And in the second era, another project that was being built out on the side, execution specs, which is Python's, it's a Python implementation of the execution layer spec as executable code. And this suddenly appears as an object on the right-hand side. And luckily, the clients can really become a neutral entity, and they actually get tested by an independent, unambiguous spec. So that really was a big improvement, and it enabled faster spec prototyping. But there was still one big pain point, and that was the tests and the specs and the tests were in two separate repositories, and they would often get out of sync, and that was a bit of a pain. That brings us to the era we're in today, which was only about a month old. So we made a bit of a push in the last few months to bring all the tests and all the test infrastructure over to the specs repository. So we merged all the test infrastructure into the execution specs repo. So we're one entity. The specs have a nice home with its tests together. We couldn't call it the merge, so we called it, because we're Steel, the weld. And this is a really nice improvement because the changes to spec and tests are atomic. So if you make a change to the spec, you see the consequences downstream in the tests, and you really see what the problems are going to be. What's the workload? It might seem insignificant in the markdown of an EIP, but when you actually go and update that in the infra, you potentially have a huge amount of work to do. So this makes the tests are no longer some dark corner of core development. They're really right there next to the specs. It's a big improvement. But are we finished? Well, Rahul and I think we're not quite finished. We've got another suggestion today to try and relieve ourselves of these remaining pain points, and they're quite significant. So at the moment, we kind of have two sources of truth. We have the EIP spec as Markdown, and we have EIP spec as executable code. And there's no tight coupling between these two things. They often diverge. And this means, because updates happen at different times, they're not in lockstep, a lot of the discussion happens away from where they should really happen, which is on a PR to the spec code, where things can be disambiguated. And I mean, of course, we don't want to stop discussions elsewhere, but it would be nice if we have one focused effort to make an atomic change on the spec in both places. And I'll hand you over to Rahul, who's going to explain this process and what our proposal is for this.
Thanks, Dan. So whatever Dan spoke about today, like the effort that we've done so far has been in pursuit of saving time. Having like test vectors, having an executable reference, and then having everything at one place is an effort to save time, and these are powerful tools. But there's a limit to which tools alone can help us. And we must bring people together to save us even more time. So today we lose quite a lot of time to these questions, unfortunately. And like we have a proposal to like look into this. So if you take this example, Tony, who is an EIP author, has a question, and then Guru comes in with a valuable insight that eventually made to the EIP. So we'd like more of this, but quicker and closer to the EIP process. And so we're doing this by adding a new role called technical reviewers to the EIP process. So your role as a technical reviewer is not just to read text like everyone else in the community, but you bring your deep technical expertise to convert English to code, meaning that you help write the executable test specs and write test vectors for a single change. And I'm excited to show you how that works. So let's say if you are an EIP author making a change in an EIP repository, each EIP will be assigned a technical reviewer. So whenever you make a change, these are GitHub code owners who will be pinged when you make a change. They will take action to execute that in spec. And they will also write test vectors here. And then they will create a pre-release version for clients. And clients have an opportunity to review it. If there are feedback that can go in here in the cycle. And if not, the end of a change results in a test release. And only after a test release, the EIP PR is approved. And this test release is encoded into the EIP review process. And TLDR is, in goes the EIP change, out comes a feedback loop followed by a test release. So it might appear a bit paradoxical that we're doing a lot of effort and making the PR itself complicated, but we're already doing this in fragmented efforts throughout the cycle. But we believe that if we do that in a focused effort by bringing all the stakeholders together up front, we can iron out the smaller issues in the EIP and help make the EIP a little more polished. And for years, there's been a debate whether the spec is the source of truth or whether the test is. Today, we can end that debate, and we can bring back like the test release vectors as an artifact of the EIP itself. And by design, they're in sync. So if always a change is encoded into a test release, you don't have to figure out. So whether you speak English or you speak code, you can always bookmark this page, and you can be sure that you're on top of the latest of an EIP. And you get versions for free. So we're excited that to bring this new role to the EIP review process. And we hope that finally all the Ethereum changes are atomically bounded into one package that contains both the pros and the text and the test to accompany them. And we hope this creates a faster release cycle.
All right, so basically Rahul explained how we want to tightly couple this, and we almost have everything we need to do that today. We have the specs and the tests together in the execution specs repo, so we have re-infra. On the infra side, we're complete and ready for this. And very soon to be merged is Alex and Tim's network upgrade inclusion stages EIP, which really explicitly states for scheduled for inclusion for SFI, you really must have a Python implementation with tests and have that pointing to execution specs. So we must have an executable stack in order to go to the next stage. And just to make it clear, as Jihoon described the journey of an EIP before so nicely, this is really not for early stage EIPs. This is for EIPs that are really considered for inclusion on mainnet. So how would this look, just to summarize quickly, using our nice boxes on the right-hand side. So as you can see on the right-hand side, if we make this small change, we get a tight coupling of specs and markdown. So we get the executable specs and the markdown specs tightly coupled through a process. So the improvement really means that someone from the spec team or someone else who's qualified to do this work, it can be someone else, can evaluate the spec changes at the source of the change in the EIP's repository. So when a change is triggered, it goes through the whole cycle of being checked through the spec. As Rahul mentioned, it's really nice because the EIP's page on the website that everyone's used to, that everyone goes to check what the status is, that can still be the source of truth, and it links back to a tagged version of the spec in execution specs or consensus specs so that you can really see what the specs look like at that version of the document. And basically, as Rahul said, we're just here to try and save time. So this can lead to faster hardening of EIPs and save all that downstream testing effort, all that effort of clients making client implementations for specs that are changing, try and target and get to the final product a bit more quickly. So, of course, nothing's perfect, but we have to find a balance between process and flexibility. I mean, we think that most issues can be solved by a social consensus, which is basically the situation now, so that's fine. It's not too intrusive on the EIP process, so we don't need to mess with governance and have too many rules set in stone. We think it's flexible enough. So, thanks a lot for coming, and yeah.
What are other proposals which are being considered or being discussed for the next upgrade? I would like to invite Maria to maybe talk about EIP 8007. Welcome, Maria. Just some explanation going on in the background. Please give her a big round of applause, Maria.
Hello. Thank you for the warm introduction. So I will be talking about EIP 8007, which we can jump right to it. So this is a meta EIP, so this means that it's a collection of a bunch of different EIPs. And it's really aimed at being a directory for all the EIPs that are proposed for Amsterdam, so the next fork after Fusaka, that are focusing on changes to the gas model or the gas prices of EVM operations. And the goal of this EIP is to be purely informational. So there was so many different EIPs related to repricings that we thought it would be a good way to aggregate the information and help organize the work around these repricings, and also give more information to the community. And why are we seeing so many repricings in Amsterdam? Why are we even doing this? So there's two main reasons. The first one is that a big focus for Amsterdam is to scale the L1, so increasing throughput. And repricings on their own, they do allow us to scale further through what we call harmonization. So what we mean by this is that the current gas costs of the different EVM operations, they are not harmonized. So we know that some operations are overpriced, so they are more expensive than they should. And this means that we are essentially limiting the throughput of that particular operation. So instead of being able to fit 10 operations, we are only able to fit 5 because they are too expensive. And for other operations, they are underpriced, so they are too cheap. And these are even worse because that means that they alone become a bottleneck to all the other operations. So we cannot increase the gas limit because they essentially create a single bottleneck that could lead to a worst case block that would take more time to execute or would hit another limit. On the overpriced operations, I'm showing here a plot where you can see the efficiency loss per opcode. So when I say efficiency loss, what I mean is that how much throughput are we losing because of the pricing we have, considering the actual execution time that the operation would take. So in the ideal world, with the execution time, we could fit an X amount of that operation under 2 seconds. We can also calculate with the current price how many operations we can fit within the gas limit, and we take the ratio for this to get the efficiency loss. And so you can say this is focusing on the pure compute operations. And for a big majority of them, we actually have efficiency losses of 5 times until 15 times. So this means that for some operations, we could fit 15 times more of that operation in a single block if they are correctly priced. And then for the next 2 box plots, you can see what it would look like with a more accurate pricing. The middle one is an accurate pricing that would not go fractional. So we would still have operations that should be, for instance, 0.1, but we need to round them up to 1 because the gas model is not fractional. It needs to be an integer. And the final one is like we could solve all of that with a fractional pricing. But it's just to give you a sense of the level of throughput gains on individual opcodes that we get from fixing their prices. And for the underpriced operations, the way to look at this is, so we have this benchmark that is being work done by both the Steel team and some other people at the EF and also the Nethermind client team, where you are benchmarking different test cases for different operations. And that will give you a performance of milligas per second. So how much milligas of that operation per second can we execute? And you can see like the performance varies widely, right? Essentially, you should have all operations at very close milligas per second. Like we shouldn't have more, some operations that are more expensive than others. But it also tells you like if we want to target a specific block limit, so let's say we want to target 100 milligas for a 2-second block, then we should have all operations at least 100 milligas per second, or sorry, 50 milligas per second. And so everything that is performing worse, so it's less than that, they are creating these bottlenecks, so they need to be more expensive. And this is the reason number one. So the reason number two is essentially by doing the repricing, we are actually unlocking scaling from both headliners. So in Amsterdam, we have right now two headliners. So the first one is EPBS, which is changing the slot structure. So when certain things happen at certain times in the slot. And essentially, EPBS will give us more time in the slot for execution. So we'll have, instead of having 2 seconds, we will have, for instance, 4 seconds. And also will give us more time for data, or bandwidth, let's say, like the propagation time for all the data. And also because of the PTC deadline, the actual relationship between execution and data will change. So we'll have now more time for execution in relation to data. And then we have block level access lists. So this headliner essentially introduces the possibility of doing execution in parallel. And also, state root calculation can be done right at the beginning of execution. So you don't need to wait, you don't need to execute the transaction to then start doing the state root calculation. So again, it gives us more throughput for execution, but because some data is being added to the block, which is the block level access list, then again, it's putting a higher burden on the data resource. So we are using more data now. So what this essentially means is that first, we are adding more room for burst resources. So we are adding more room for execution, for state I/O, for data, but for state growth, which is how much the storage layer, let's say, is growing, that doesn't change. Like the available resources there don't change. So everything needs to become cheaper in relation to state growth. Or say in another way, state growth needs to become more expensive. Otherwise, that will be a single bottleneck. And at the same time, data in relation to the other burst resources, so compute and state I/O, needs to also become slightly more expensive because now the relationship between them is also changing. And so in summary, it's like these headliners are great. They are giving us more throughput, but we can really just squeeze, we won't be able to squeeze all that throughput gain until we reprice these things. And so how are we actually doing this? So the Meta EIP has 18 EIPs, which is a lot. Core devs are currently going crazy with the amount of EIPs they need to review. And so I'll try just to give a quick overview of them. But essentially, there's like 3 main types of EIPs here. So the first one is broad harmonization. So this means it's EIPs that are changing broadly all opcodes on a single dimension, like compute, state I/O, state growth, intrinsic cost, and so forth. They are doing essentially an harmonization across the entire resource. Then we have pricing extensions, which are specific changes to some component of the gas model that are not an harmonization, but are sort of unlocking some further scaling in a specific component. And finally, we have some supporting EIPs, which are mostly things that are not really impacting scaling per se, but are or are sometimes not necessarily a gas repricing directly, but they are supporting the other EIPs. And how to think about all these EIPs. So we are now in the process where we are discussing which EIPs to select. And the way I'm thinking about it is we should prioritize the broad reprice EIPs. So this means we know that we need to reprice compute, we know we need to reprice state growth, we know we need to reprice state access and data. So these are the core things, like a core group of things that we should harmonize so we can remove the single bottlenecks and the underpriced opcodes. And then there's like these supporting EIPs are more a menu of choice, right? We can take, okay, this extension is nice and we should have it, or this extension is not so needed now and we can leave it for later. And so I think the way that I try to group these things is like the broad first level repricings are a bundle. They need to be done together, because if we change something and we don't change the other resource, for instance, we'll be just introducing bottlenecks and doesn't make sense. And then the pricing extensions we can add as we go. And so what comes next? What are the next steps? So now we are in the process of deciding which EIPs to select, and we already have some signals that repricings in general will be a core focus. However, there are a couple things missing. So first, some of the EIPs, or a big part of at least the broad pricing EIPs, they are still not fully defined. And the reason for that is that we are still working on the benchmark to actually collect the how much time things take to execute, so that we can set the final numbers. And we are currently starting to get the first numbers on this, but it's still a work in progress. And then we need to decide on the scope. So which operations are we prioritizing, which of the additions should be added. And then another big thing is state growth. So all the other operations are sort of simpler because we can just benchmark them, say, okay, this operation with these parameters takes 100 milliseconds, and so their price should be X. This is fairly simple. State growth is a bit more complex. Like, we kind of have to take a guess on what state growth rate we should be targeting, and this is sort of, it's not something that we can benchmark directly, so it's a bit more nuanced. And then there's also different flavors of how we could reprice state growth. And so I think this one is sort of a very important thing and something we should definitely do, but the exact flavor of what will end up in the EIP, it's still unknown. And thank you. So I think we still have some time for questions.
Yes. Yes, very much. We have some time for questions. Do we have got questions for this specific EIP or even gas repricing in general? Please raise your hands. By the way, quickly checking, did you guys get the idea of why we have this EIP in place for the first time? No, actually it is not for the first time. Maybe for gas repricing, this is for the first time. But we have seen such kind of EIPs in the past where we try to put all the related proposals in one place so people can learn it and say which one they would like to see in the next upgrade. Any questions here? I guess you are good, Maria. Thank you so much for sharing about this proposal. All right, so far we have looked into a few things. First, we looked into the overall process of EIP, what EIP is, and how we try to draft the proposal. Then we looked into how proposals are considered for network upgrade. Of course, we learned into the work that goes behind the scene, the testing thing, the test case making things, and things like that. We also looked into the proposal, which is kind of list of many other proposals that can be considered for the next upgrade. We also have one speaker talking about how the documentation of proposal can help us go to the right from draft to the final status. Actually, the proposal isn't in the final status yet, but yes, how we can proceed with the proposal. Now we want to touch base on the human side of this. We would like to invite our next speaker, who is working on the application side and would like to share his journey as an author for the first time. I would like to welcome German.
Hello. Hello everyone. Thanks for having me here. I'm Herman. Duplicate. Okay, gracias. I'm Herman Aval. I was invited to create this talk from idea to EIP, a first-time author journey. I am a first-time author journey. I was doing my research. I was checking how to make it. It's not working. Debería estar funcionando. Ahí le está agarrando el proyector. Sorry, some technical issues. Tiene que estar funcionando.
Ahí acá se conectó. Listo.
Sí. Okay, thank you. Okay, we go with the presentation. This is based on my experience on ERC 8003, ERC20 pre-initialization extension. You can scan the QR code to see more details about it. And I will start. So why create an EIP? So this is a question that was made in the public. I guess from people like me, that was why should I create an EIP? I see all that specifications, I see how valuable they are, and I think I have a new idea that can improve the protocol, can improve the infrastructure. There is new use cases that can be made consensus in an EIP. So this is very important. So we need to have something to work on that is needed or is going to improve Ethereum. So we can document patterns that are already happening but are not documented, so we make a standard as well, or to coordinate the community around a common solution. We saw this in the past presentations. So, second, research and self-validation. We think that we have something that we are going to improve Ethereum somehow. Now we have to research and we have to self-validate us, so we avoid wasting time of others from the newbie perspective, going to a forum, taking the time from the experts that they are kind and they will reply us and they will try to explain, but we have to take advantage of all the effort. So don't make Ethereum lose time for you if you didn't make your own research. So first, if you have something that you want to propose, if it's code, do it. Do it in your own code. Make it real, not just an idea and go there and write down. It's valid if it makes a lot of sense, but anyway, you have to validate the idea. Second, after you have the code, or you have the idea or the consensus or whatever, start to find errors. You have to go against yourself and also to your contacts, some devs, some Ethereum people that is also improving. Find limitations, try to push it to edge cases, iterate, as it says, until it survives your own critical analysis to the maximum. Then create, if it's applicable, a mini site, a repo, a documentation with exactly a technical rationale of it, use cases examples, and metrics. And whatever else that you think will go forward to justify why are you doing this and how it works, and it really works. So in my case, in the example of ERC 8003, I had a problem that was gas fees spikes. This ERC is about pre-initializing token accounts, ERC20s, before have balance. So why I did this? Because I want to prepay the initialization of the slots of the ERC20s, so when you make the first transfer of real balance, it will be 33% cheaper. So I had a problem. Then I was testing. I create some contracts. I deploy it, and I start testing. And then I had metrics. So finally, I got metrics of how much do you save, depending the gas price and the gas price now when you pre-initialize. So about this, I can show very easily how I did my proposal. Here, I started, I put my repo, then I justify it, then the background motivation, proposal, specification. The specification is very simple, but here I put this extension route, reference implementation in Solidity, conceptual savings calculator live, and real testing results that are very important. So in the calculation that is live, you put gas price, current gas price, calculate, and here is information. So this is just to show you that you need to prove what are you doing. And very important, learn to propose and discuss. And this for me was very important because there is something that is called netiquette that I don't know if this term still is working, was when I was 25 years ago. Was like behave on the network as well. There is some rules, there is some important formalisms, and in every forum that you get, there is a way to communicate. And I found this proposal, that is not mine, with a lot of activity, very useful, because was a lot of exchange of opinions, many cases, because some person proposed something, other person came to say, I already proposed it, come with me. And then they say, no, this is different. And then more people came and start showing why it's different, why is a different point of view, which are the differences. So a lot of justification in both sides happened. Also some improvements in the middle as well. People saying, okay, but I want to add this, but it's a thread. So it's very complex because in the meanwhile, they were getting a conversation of, this should be part of another ERC that is already approved, or this is a new ERC or EAP. And in the meanwhile, I was suggesting to change some function, and this is in the middle of the conversation, and the author has to take care of all this, but also other people came supporting the author, or better say the proposal, to answer as well. And you start getting aligned at the end of the day. Without this alignment, while the discussion continues, with sense, of course, that is in almost all cases, you can't move forward, because if not, it's a waste of time. So this is very interesting how it happens. I really recommend this discussion in particular. I really like it. And well, now comes the proposal timeline for newbies. We already saw what happens on the validation side, all the iterations, all the logics, all the workflow. But for us, that we are making this for first time, first we have to have the problem context, an abstract, motivation, specification, rationale, security, link to the repo, and following the standards, the EIP 1, that is the QR code there. It's very important to read it. You can read it before, you can read it after. It makes a lot more sense if you read it after a week researching Ethereum magicians. If not, it's too much specification for nothing, because you are standing on nothing. Then you have to make the pull request. You will receive an EIP ERC number when the request pass the first filter. Then you will include this number in your prop, and here start the problems. You have to rename your file. You have to do the pull request. You have to change a lot of information inside your MD file, and the bot comes. That was a nightmare for me. The EAP review bot throwing thousands of errors. It can give you 8 items, but inside an item can be like thousands of errors, and then there is one error, but when you solve it, you solve it, it's fine. So now come 100 errors, because the error that you solve open a door for finding more problems. So the best is to debug manually. Don't use GPT. When I asked GPT about my presentation, GPT tried to remove about using GPT. He said, this is a nice joke, but it's better to say in a different way. Now, don't trust him. It's very nice, but don't use it for this because I tried to debug first on GPT and I generated more errors and it's nonsense. Do it manually, take the time to read, to learn, and then you have to attend a call with Ethereum cat herders to understand the process. Try to go to the calls, listen, and then request to your EAP or ERC to be added into the agenda. And you have to be patient, you have to wait for your slot. Maybe you're lucky and you get it because other proposals don't show up. And you present it to the call. You have to listen the feedback very carefully. And then address, adjust, and repeat. And here I will show again what happens with my proposal. When I attended the call, I was on this stage, just here. And on the call, this issue was opened, an edge case. Try to do this and show that the EAP, the ERC in this case, don't broke. I made it very fast. I made all the tests. I documented it. And luckily, it passed the review. So, implementations and integrations. After you are passing and moving forward, it's very important to file real-world integrations that demonstrates the usefulness of the EAP or ERC. So you have to start working on the traction because this will help you a lot to get approved and added if it's your goal to give some value. If not, you are just giving an idea that is very cool, but no one is going to use it. And then adapt the protocol on what you learn and create a sandbox environment for others to test. And very important, keep the proposal alive. Nobody is going to make it for you unless you are doing a super cool, great proposal that maybe you are doing, but nobody sees it before it's working. So for the ERC 8003, I'm trying to contact Open Zeppelin people to review and implement in part of their contracts, the ERC 20s, and contacting wallet providers interested in pre-initialize their users as a service to check if there is internet interest or not. So recap, your first EAP, where to start? Write down a specific Ethereum problem that is bothering you today or you think that is bothering other people. Look for similar EAPs. I also hear some questions before about this. There is a forum, the Ethereum Magicians. You can search there. You can also search on the repo of Ethereum. And I think maybe in the Discord also, the Ethereum research. And this will be enough. Do a deep looking. And in the next 30 days, if we say I start today, create a small prototype, try it, invite people to try it, start a thread on Ethereum Magicians, start your post, very sorted out with the requirements to make life easy to the ones that are reviewing it, and get feedback from people who already published an EAP and open to talk. So thank you for having me here. I hope I clarified some people path to publish an EAP ERC. And well, thank you, Poja.
Thank you, Herman, for sharing your experience and giving us a shout out. Yes, of course. The call is called as EIP Editing Office Hour. Please join us if you have question, if you are first time author, or if you in general want to understand how the process works. You may have followed Sam's earlier conversation. He had a message that we displayed in the beginning of this EIP Summit where he mentions that this is author-driven process. So if you want your proposal to become an Ethereum standard, you have to be around. You have to be around to push it to get into a network upgrade process, as well as if it is for application, if that is an ERC as well. Well, we are encouraging people to come up with different ideas and specs and implementation and be an author and be a contributor to this big, wide open ecosystem. While we have German here, if you guys have any question about like becoming the first time author or trying to maybe document a proposal, anything you would like to ask with him.
Ahoy, great talk. So my question would be, it was obviously a lot of work for you, and 33% gas saving is quite significant in some way, but were you doing this primarily in an altruistic way, or were you doing it to try to learn more about the ecosystem through having direct contact, or to see about the adoption of standards, or what was your real motivation in some sense, given the huge volume of work that it required, and given that you don't internalize all of the benefit that you are going to be producing if this is adopted?
My motivation is always saving gas. I love to save gas. I'm from Latin America. We want to save in everything. And I found this that is interesting because we hate gas spikes. Gas spike for us is a pain. Makes impossibilitate us to do something. While in other areas, it just means I will pay more. In the global south, but in Latin America happen a lot, means I have to wait. And I can do it until the gas go down. So this is an improvement that I think is saving 33% of gas on something that maybe is $1, but maybe on a gas spike, writing a balance of a new token could be $30, $40, and you want to be in because you are following this launch science long, and you are going to get out just for this. I mean, it's an improvement. It's very small effort. It's just adding a small functionality. One small functionality change how the storage is stored on the contract. In place of uint bytes 32, and then the interface remains the same, and it's a pre-initialization. It's optional, so I think why not?
That's great. I know everybody loves gas optimization in whatever form it is, if it is for like main network or for applications. So thank you so much for your contribution and documenting a proposal. But we still have few minutes. If we have any more question, perhaps we can take one more. That could be related to this proposal, as well as if you're curious or you want to learn more about how to become an author, if you're considering that one as well. All right, in that case, thank you so much, Herman, for joining us here. And people, please find him back the stage, and you can have more questions. So he just talked about a proposal which is on the application side of Ethereum. Continuing the journey, now our next guest, next speaker is going to talk about a proposal which is on the application side, but he would also let us know how his project is trying to implement that proposal. So we can know that we are not just creating standard for applications, we do have real users, we do have projects which are implementing them, and we would like to learn more about some implementation of it, as well as like support the proposal. That actually helps all EIP editors to move a proposal to final status, because for core proposal we know network upgrade is the final destination, but for application we expect that to be implemented on different projects. So please welcome with me our next speaker, Thiru Murugan, and he's gonna talk about ERC 8028, which is AI assets on chain data and anchoring token. Welcome, Thiru.
Thank you, guys. Hi, I'm Thiru Devral at Metis. So in this presentation, I'm going to talk about this ERC 8028 draft for on-chain AI assets. And this ERC proposal sets a new primitive for incentive-driven and human-aligned AI economy. And we're going to start with what this ERC 8028 draft. So it's still in EIP stage at this point. And to start with, it is a semi-fungible token standard, and it is designed and engineered just for the on-chain AI assets. And what it differs from other token implementation or other semi-fungible implementation is it's the core features are aligned with the on-chain AI assets, which includes tokenization of data models, tokenization of like AI agents themselves, and it also includes the implementation to create a fair and deterministic revenue distribution whenever on-chain AI assets is being used, as well as having the usage quotas. And this ERC 8028 draft, this token standard is called as data anchoring tokens, and it is built in-house by LazAI, which is a part of Metis, and it includes the bundle of ownership certificate, usage rights, as well as the revenue sharing. And it have 4 major metadatas. This token have metadatas, of course, and these 4 metadatas includes the unique ID for each individual tokens, and this unique ID is for like all the assets, includes the models, includes the data, include the agents, and includes the labeling. And the second metadata is class, is for the categorization, and the value. The value suggests the revenue sharing, the usage quotas, as well as the usage measuring. And it also includes the proof for the authenticity. And for DAT implementation, the proof can be integrated in many ways. It can be ZK proof, or it can be any other proving mechanism can be included. This infra is very much interoperable between various technologies. And what does the DAT standard solves that the existing standards doesn't? To start with, the existing standards can be ERC 20, 721, or any other standards doesn't built or engineered especially for the on-chain AI assets, and there's no implementation that natively supports usage quotas or revenue distribution or core revenue. So there's no way we can able to track a particular token's utilization or particular tokens provenance of usage in any inference or any data training. So DAT solves it by providing the implementation for usage measuring and as well as the deterministic revenue sharing. It also comes with like the updation of the like tokens metadata as well. And to begin with, it also have the off-chain payloading, where the data can be anchored off-chain and the hashes can be anchored on-chain. Yeah. So let's also check out the DAT's life cycle. So to also remember that DAT is the name of the EIP 8028 standard, and it is implemented through the Alet SDK. And Alet is a SDK that have implementation in 3 major languages, which is TypeScript, Python, and Rust. And using this Alet SDK, anyone can able to build an agent, AI agent that have use case for any like any tracks, and this agent can able to mint the DATs as well as to use the DATs from the DAT marketplace. And this DATs can be used for inference, data training, or the model training through the LazAI API through private inference. What private inference means? The data is contributed in an encrypted manner. So when data is in encrypted manner, it is not transparent. It is not like publicly available transparent data. So it is encrypted and stored in a DA, it is in IPFS or any storage nodes. And this encrypted data will be used for training. And how anyone know like what particular token includes? That's where the metadata comes in. So the metadata shows the category, value, and the proof as well. So whenever this data is used by any agent for either inference or for training the model, the data contributor will get paid. So data is contributed by individual, and it will be like contributed through the IDAO. So IDAO is a similar DAO implementation, but it is for moderating the data contribution, labeling, and categorizing. And it is the data is contributed to the IDAO, and it is traded to the DAT marketplace. And last pad is a agent token launchpad, which is for creating the value for the data being contributed. And the core feature. The core features comes with, first of all, it is a semi-fungible implementation, and it plays well with other ERC standards. For royalties, which is 2981, and for the slot mapping, which is 3525, and as well as for the rentals and roles, for which is for like renting the DATs for usage, which is 4907 and 5006, and it have the minimal on-chain interfaces. So when it comes with like playing a role on like AI training or the model training, the strain would be huge. That's where the DAT comes with this minimal on-chain implementation, which includes the record usage for tracking the records, which provides the feature for the like usage quotas, and the transfer value. So whenever a write or the DAT is being transferred, this implementation is enabled. And the settle revenue ETH or ERC, it is for the revenue distribution whenever the data is being used by any agents or models for the inference. And the claim is for getting the payout for the contributor. And the metadata URI. So here where the off-chain implementation comes in a sense, the data is being anchored somewhere, and the hash can be anchored in the on-chain, and we use the hash of the data in the metadata URI. And why this on-chain agents data asset, like why the assets for the on-chain agents have to be anchored on-chain? It comes with the proving the usage of a particular data for the inference. An inference can be influenced by like number of datas, number of DATs. So whenever an inference happen, we can able to track what are the DATs that influence the model to result in a particular response. So we can able to track in the same way that inference fee will be distributed to all the data contributors of those DATs. And it is modular because each DATs can be pieced together to able to train or for the inference as well. And it provides a deterministic revenue sharing for the data contributors. It also incentivize them in a way they can able to contribute. The contributors can be an individual, the contributors can be organizations, or the contributors can be the researchers who works with a lot with data. And the main features of the DATs comes with providing and anchoring the DAT, the on-chain assets for training the AI agents, training the AI models. So providing, in a sense, this is the first part, which is the data required for training the AI models. And anchoring, in a sense, where the data is being hosted, so it can be retrieved for the training purpose. So the providing sense is what when the DAT is being minted, and it will be anchored on the chain for the usage later for the private inferences. And the on-chain provens where the data integrity is checked through the hash, the metadata URI. And the agent negotiation and marketplace includes where the DAT will be listed for others to use. So whenever they pay for using those DATs, and the data contributors will get those reward in a fair and deterministic manner. And the use case includes any kind of DAT implementation for any tracks, include like healthcare, for collaborative AI projects, for DeFi strategies where multiple like trading agents can come together, share their ideas, and to build one. And whenever a particular implementation or particular strategy works, the contributor will get the reward for that. The monetization workflow starts with encrypt and upload. This is where a user or researcher or anyone can able to provide their data, and they provide the data, sign a transaction. The data will be encrypted and stored. And the second step comes with like this encrypted data stored on chain through IPFS, and the URL will be stored in like LASI chain, and the user will get a DAT. This DAT will have the track whenever the data is being used, and whenever it is used, it also provides the reward for them. And the third step, the third phase, is earning rewards. As I mentioned, anyone uses those particular DATs for inference, the contributor will get the reward. And where this value comes from, so whenever the inference is requested, the inference user have to pay inference fee. That inference fee will be directed towards the data contributor, data labeler, data categorizer. So every user or every candidate involved within this AI flow will get the reward. And the fourth is the proof and validation. And data is contributed, someone use it for inference or training, and when they use it, it will show each and every DAT that have a part in this particular inference. So it can be tracked, it can be backtracked from the starting where each and every DAT is influenced and each and every inference request. And why this ERC 8028 draft is a big breakthrough. It starts with, it is a semi-fungible token standard which is very user-friendly for developers, and it provides the A, B, C for on-chain AI assets. So first is anchoring the data provided by the users, contribute. The deterministic fast sharing, whenever the data is being used, the contributor get paid fast, deterministic way. And C for composability, it plays well with other ERC standards, other token standards. So there's no issues with working together with other standards. And it also provides a frictionless onboarding for devs, for AI agents, and any kind of on-chain AI applications. And it's not just in the paper, and there's a real world example. There's a application that is live which have thousands and thousands of transactions, which is Last Boo Boo. Through this application, anyone can able to contribute their data. We have already like more than like thousands and thousands of DATs being minted, and these DATs are listed in a DAT marketplace. Any AI model trainers can able to use them, and for that, the contributors will get a reward. And DATs includes any kind of data. It can be voice data, it can be like textual data, tabular data, charts, research data. So all kind of data is included, and every DAT contributor will get a reward whenever this DAT is being used. And with Metis and Laz AI, we can finally able to solve this data alignment problem, and that's the whole point of this whole draft of DET and the ERC 8028 draft. And here's few skewers, which includes my Twitter and Laz AI and Metis Twitter, and also the Laz AI docs if you want to check out how the DET works in real for developer experience, and also the DET thread in Ethereum Magician website. If you have any questions, I would be love to answer, and thank you so much for listening.
Thank you so much, Thero. I understand AI is a hot topic right now, and you also talked about semi-fungible token. That's right, yeah. So fungible token in general people love, non-fungible token definitely yes. Now this is semi-fungible token. So we are getting standards for all sort of application, all sort of projects that we can think around Ethereum ecosystem. We still have a few more minutes left. If people have question on this particular token, which is there for AI application of it, or about the project itself, please raise your hand. I know this is a kind of early era of like adoption of AI as a standard. We really appreciate your contribution, the team's contribution, and we would love to learn more about it. But perhaps we can record a full episode. For people who aren't aware, we do a podcast called PEEP and EIP, which also includes ERC, of course. So there we go through the proposal, what is the proposal right now, the high-level overview, as well as some technical details. And there is another podcast that we do is called Ecosystem Project Demo. There we find the real-world application of that particular proposal. So I think this is a very good candidate for both of them. Thank you so much, Thero, for joining us here today.
Yeah, thank you so much for having me.
All right. So now we have covered an ERC as well. That was just for setting the stage of like how we are inclusive of accepting all sort of proposals. The next speaker here could not join us in person, but he definitely has a message that you would not want to miss. He is our own editor, Sam Wilson, who is going to guide us through the entire EIP process of documentation. We do have a video from him. I would request an AV team to maybe put it on. Yes, that's perfect. So it was supposed to be a workshop, but unfortunately we could not connect with him on Zoom right now. So instead he sent us a recorded video, which we are going to play right now. But if you guys have any question, I'm happy to take. Maybe I can respond as much as I can. Otherwise, I would invite everyone to join us on EIP Editing Office Hour. That happens almost every Tuesday at 1600 UTC, but people can know about it in advance by checking out the Ethereum/PM GitHub repository, as well as Ethereum calendar, Google Calendar, if you are subscribed to it already. Yeah, so can we go ahead with the video, please?
Hi, welcome to the EIP Summit at Devconnect. I'm one of the EIP ERC editors. My name is Sam Wilson, and I've been asked to talk a little bit about the EIP process, what makes a good EIP submission, and what authors can do to kind of make the editors' jobs easier. So I guess a little bit about me first. I work on the STEEL team at the Ethereum Foundation. That's the specifications and testing in the Ethereum execution layer. We work on a Python reference implementation of the Ethereum protocol. And that gives us a pretty good overview of how Ethereum works and gets us really deep into the whole specification process. Yeah, so I guess let's talk about what makes a good EIP submission. If you're not familiar with the EIP process, the first thing you have to do is open a forum thread on the Fellowship of Ethereum Magicians forum. This kind of gives you a starting point to discuss with other authors and other people involved with the community about your proposal, whether that's EIP or ERC. This helps avoid duplicate proposals and kind of collects people's thoughts into a single proposal for a particular topic. We don't need, 300 different soulbound token standards. We need one soulbound token standard. And if that coordination is done before the proposals are written, there's more opportunity for collaboration. Once you've kind of reached consensus on a topic and how you want to implement it, then the next step is to open a pull request with kind of a draft of your proposal. It doesn't have to be complete. It doesn't have to be technically finished. It just needs to give a kind of overview of the solution that you're trying to propose, and that's good enough for a draft. Eventually, an EIP editor will take a look at your draft. I will provide some feedback, mostly on formatting and adherence to our rules. An important thing to note is that EIP editors do not generally provide technical feedback. We only provide formatting, grammar, that kind of thing. Technical feedback is the responsibility of the author themselves. They have to find the correct reviewers for a proposal. If it's a core proposal like an EIP, your reviewers are probably going to be core devs. If your proposal is an ERC, you need to find people in that particular subject areas. So for example, if you're writing a new RPC endpoint proposal, you're going to want to talk to wallet developers. You're going to want to talk to client library developers. Figuring all of that out is kind of the first step. Once the proposal is technically finished, then you can move that proposal into the review stage. Again, this is a pull request, and an EIP editor will take a look at your proposal. Once approved, your proposal will move into review. This is really where your proposal should be finished and technically complete. This is where you're going to be getting the majority of your feedback. Once you, as the author, are happy that your proposal has received enough feedback, you open a pull request to move it into last call. It's generally 2 weeks, and once that's complete, you can move into the final stage. Something to note that's very important that a lot of authors miss about EIPs and ERCs is that once a proposal goes final, it can no longer be edited. Any future changes have to be made in a new proposal with a new number. So it's very important to get your proposal correct before you move into final. We want the EIP and ERC repositories to kind of stand alone as an archive of the decisions made in Ethereum. That kind of has some implications that are kind of annoying for authors. And trust me, they're annoying for us editors as well. The biggest one is external links. So let's say, you're writing your proposal and you want to link to Vitalik's blog post on a topic, or you want to link to a company's press release about a new technology they're proposing. Unfortunately, we don't allow that because links change, these things disappear, and it's very important that we have a complete record of the decisions made in Ethereum. So we do provide some kind of tools to cope with this. The one we prefer, generally speaking, is if the content is under a compatible license, you can move it into your assets directory, and then you can link to it from there. That way the content lives forever alongside the EIP itself in our repository. If the license isn't compatible, which is unfortunately pretty common, we do have some exceptions for links that you're allowed to make. The big one is for academic papers. Anything that's assigned a DOI number, you can use as an external link. There are some examples in EIP 1 of how to cite those things. There are also exceptions for RFCs, like IETF RFCs, U3 standards. Generally speaking, will allow any document source that has existed for a long time and is likely to continue to exist. But if you find something that isn't allowed, you can ask us to make an exception, and there's a good chance we'll do it. For more information on that, you can take a look at EIP 5757. Let's see, what are other common challenges that authors face? A big one that I always notice in proposals is the difference between rationale and motivation, or rather, I should say motivation then rationale. So motivation is where you kind of explain why your proposal is necessary, where the rationale explains the choices that you make in the proposal itself. So kind of a contrived example here. Let's say we're making a proposal to build a shed to store, let's say, an Ethereum server, right? We need this, the motivation answers the question, we need this shed to keep the rain off the server. We need this shed to provide physical security for the server. So the motivation answers the general questions of, why we need the shed. Whereas the rationale would answer questions like, we painted the shed red because that is the style of the time, or we decided to make the shed out of steel to provide increased security. So the rationale section provides information on why you made choices in the proposal itself. How the EIP process has evolved. That's an interesting one. So I've been an EIP editor for a couple of years now. I wasn't with the program when it started, but I've definitely been here a while. I've kind of seen the EIP process evolve, and I've kind of shepherded a little bit of the evolution. So earlier on in the process, it was very informal, very rough consensus based, and that definitely had its advantages. It was much more easy for editors to kind of come to decisions and difficulties, but over time that became a bottleneck in our decision-making process. So we formalized our decision-making process into the EIP Editor's Handbook. The number escapes me at the moment, but if you're curious, you can go read that proposal about how we make our decisions, what criteria we use, what our overall goals are. It's kind of our manual of how to be an EIP editor, at least on the governance side. So that's probably the biggest evolution recently, is codifying our, I don't want to call them bylaws, but bylaws. How editors and authors can collaborate more efficiently. So the primary point of contact between editors and authors is through pull requests. I do also run office hours, as do some of the other editors. The schedule is available on the Ethereum/PM GitHub repository. Following our rules is probably the biggest thing. If you look at EIP 1 and other proposals and just try to copy how they have successfully been merged, newer proposals for sure, don't be copying like ERC 20. Yeah, so using EIP 1, looking at other proposals, and just having everything ready before an EIP editor gets to your pull request is going to help us immensely. Another one is responding quickly to feedback. So if we leave a comment on your pull request, resolve it as fast as possible so it doesn't sit there. That'll help us out a lot, because we do have something like over 200 pull requests right now, and the faster we can get through them, the better. Any advice for new contributors or future editors? Future editors is a little bit easier to answer. You're going to want to talk to existing editors and figure out what their individual criteria are for adding a new editor. So personally for me, I like to see a history of successful edits, successful reviews on pull requests. So if you're planning to become an editor, start leaving useful feedback on other people's pull requests, and that'll be super helpful for us and demonstrate your ability as an editor. And another one here is just alignment with Ethereum in general. So we want to see that you believe in decentralization, credible neutrality, and believe in Ethereum itself, that there's a reason to build this platform and that you're passionate about it. And that's probably the biggest criteria that I have personally for becoming an editor, is just being passionate about Ethereum. It's also important to note that you don't need a hugely technical background to be an editor. Most of our job is reviewing grammar, spelling, and adherence to content rules. And that's intentional so that we can get more people involved in the EIP editing process. As for new contributors to the repository, that depends on what type of contributor you are. If you're a software developer, there's a rewrite project that I've been putting off for a year now. I would love to get some help on that. It's written in Rust, so if you're a Rust developer and you want to get involved, hit me up. I could definitely use the help. If you're, more on the product side or on the, just enthusiast side, just providing useful feedback to other people is the biggest thing. Yeah, I think that's pretty much it. Anyways, yeah, so thanks for coming to the EIP Summit. I'm sorry I couldn't be there in person, and hopefully talk to you soon.
Thank you so much, Sam. Sam is one of the most active editors we have around, and he always shows up for office hour. You could also talk to him outside the office hour. You can join our Discord, the ECH Discord, where there is a dedicated channel for EIP editors. And yeah, of course, you can share questions. Sam did mention about the process in general, and he mentioned about the subject matter expertise. Yes, we are looking for people who can be a subject matter expertise for either on protocol side or on the application side. If you are interested, we do run a program which is to onboard EIP reviewers. So please reach out to us, and we would be happy to include you and make you a participant of the program that we are trying to run over here. Earlier this morning, we also noticed a presentation by Dan and Rahul where he shares the idea of future process improvement, how we can have reviewers assigned, technical reviewers assigned for maybe for core proposals. I don't know if that was intending for application side as well or not, but yes, that is still a dream. I believe it is possible. We will have to look into the process, and we will need more participants to help out with that process. So if you have any expertise, any interest in helping out with making Ethereum standards, please reach out to us. Last but least, Sam did mention about the support that we are looking. So basically, we do have multiple bots which are running on Ethereum /EIPs and ERC's repository, and we are looking to improve the bot in order to minimize human intervention to make the proposal move forward. If you have expertise with Rustbot or any other bot that we are currently running on Ethereum /EIP GitHub repository, please reach out to us, and we'll be happy to introduce you to the team and be very, very thankful to you for helping us with the bot which can help us improve our process. With that said, I think we can perhaps move ahead with our next talk. This is a very basic talk for a proposal which I believe most of the people coming into blockchain ecosystem wants to learn about. The proposal is EIP 1202, which is a voting interface, very simple voting interface. And unfortunately, the author could not join us here in person, but he has shared a video talking about this proposal, and he is also one of the ERC editor. So we would love for you to maybe follow this video, and if you have any question for this proposal, maybe you can share that. And yeah, you may also find him on EIP/ERC editing office hour.
Hi, everyone. Thanks for being here. This is Victor Zhou, the lead author of ERC 1202 voting standard, and I'm also one of the EIP ERC editors. It's my pleasure to introduce you to the effort of ERC 1202 voting standard, and we look forward for your participation in its discussion, adoption, contribution, and please check it out. Our domain name is ERC1202. We'll publish our updates there, and you can see a lot of other ways to participate. So first of all, let me give you an overview of why we are standardizing ERC 1202, why we are standardizing this voting standard in general. We happen to believe that the biggest power in the blockchain and Ethereum is being able to make commitments, make promises, but in a very interoperable and compositive way. So we want to be able to build this voting primitive for governance and for many other use cases, right? You have a DAO, people vote, you have a protocol, there's a decision that needs to be made. And in real world organizations, there are boardrooms, there are shareholder meetings, there are voting that comes with, like, people can have homeowner association, people can have class committees, and many other things that needs the decisions together. And there's also things that people don't normally think of it as a voting, but in fact can be represented in voting. For example, multi-sign signatures, or polls, surveys, or prediction markets, right? So there are many things that can leverage the voting. Imagine voting is you can use it in any wallet, and it's adopted by most of the DeFi protocol. You can just do it on-chain. Or if there's a way to standardize the off-chain signature verification, we can also make it off-chain to on-chain. So We have big ambition for voting standards. We just need some consensus of how they will be represented. Today, we are sharing this vision, and we would love to gather feedback from you. We have some iterations of our draft. Please go ahead and check out on eips.ethereum.org, or you can also go to erc1202.org to find the current draft, and we look forward to your input. Okay, I'm a little bit too far. The general theme is that we want this voting standards to define these interfaces, events, and behaviors for like creating proposals, managing them, executing votes. It focuses on the entire life cycle of a proposal, ballot types, result interpretation, and we hoped that we'll be able to integrate with aggregators, explorers, wallets, analytics, identity providers, and hope that governance can be a plug and play instead of bespoke engineering for every new community. And we also want this to be able to be flexible enough to support most of the voting schemes, right? Today it's like one person, one vote. Maybe in the future they will be token weighted, quadratic, delegated, ranked choices. There are many different voting mechanisms. Multi-layer voting support and also weighted by ERC20, ERC721 if it's an NFT, or ERC1155, right? So hopefully in 2025, voting has a lot of new context in this standard drafting, and we wish that we will be able to gather your input. What you see needs to be there in a draft of the voting standard. There's many use cases, right? DAOs, RWA, prediction markets, as I mentioned. There's also ecosystem grants, like important decisions to be made, community events, compositive, and also we hope they can be composable with identity and more importantly, reputation. If you want to determine like who you want to vote for, or do you want to delegate votes to, or who do you want to follow votes from? You want to follow your votes off, right? So currently we're at the draft refinement. We already have some draft over the past few years, and we also get feedback from last time, actually Istanbul. In the next quarter, we hope that we start to fan out in creating reference implementations with more or less finalized draft. And Q2 of 2026, we hope that it becomes the major time for adoptions. So we look forward to drive this effort with a lot of stakeholders and hopefully, and also people who want to build and who want to advise. The core stakeholder we believe to be DAOs, protocol teams, people who are looking for safer and standardized governance, and hopefully similar to how Quanti has different implementations and then people start to create them. So once you adopt to issue one ERC20 tokens, it just appear and interoperable to all different wallets. We hope this voting will become this way as well. There will be infrastructure providers like wallets, explorers, analytics, identity, and attestations, right? Or there are systems that heavily rely on voting, right? L2s, roll-ups. And we also look forward to advisors and collaborators or even co-authors if you're very active in drafting EIP ERCs, if you're security contract, smart contract security researchers and audit firms, or if you have expertise in corporate or RWA governance. And this section, we want to talk about how to join the initiative, right? What you can do is you can review and comment on the draft. You can pilot ERC 1202 in your DAO or product, share your feedback or edge cases. You can also join working sessions and discussions, join our channels, Discord, Telegram, our ETH Magician forums. You can also contribute. The biggest contribution that we will need is reference implementations, right? And then also audits, toolings, education would all be great. Now, how do you stay in touch? The canonical place is erc1202.org, also where you can see our draft. And there's also GitHub repo, X, Discord, Telegrams. We look forward to your participation. Thank you so much. This is Victor, and we look forward to your participation in ERC 1202 standardization of voting. Thank you.
Thank you so much, Victor, for sharing that. I understand, unfortunately, you cannot join us here in person, but it's good to have information about the proposal, which is very simple to understand, and we are still waiting for it to become a standard. So thank you for sharing that. Well, we still have a few more minutes left. I remember I mentioned when we were talking about Sam that if there are any further questions, I am happy to take it. We'll try to respond as much as possible. If not, then I can pass it along, and we'll be, trying to respond it in editing office hour. So just quickly checking if do we have any questions. All right. So that is good, and that is pretty much what we have got for you here in EIP Summit. I think we have tried to cover end-to-end. As I mentioned in the beginning of this conversation, that we consider EIP to be a song, a record, and Ethereum network upgrade as a live concert. I hope with this EIP Summit, you would be learning more about EIP's network upgrade and application, and may you consider joining us to help out make better Ethereum standards. I would like to take a moment to extend my thanks to all the speakers who has joined us here today, and the client team members and community member who took out time to join us here, as well as follow us on the live streaming. Well, we are very much hopeful that you are going to join us one day, if not today, but one day in this EIP process. As I mentioned in my slides, Ethereum is not an end product. It is a living process, and everyone has a role to play in it. So please join us. Thank you, everyone, for coming out here today.